Hi folks, this lesson is on distance, speed and time, and we'll be looking at calculating each of these separately. Okay, so first of all, just a wee introduction on what I mean by distance, speed and time. So distance, first of all, when we're talking about a journey, this is just how far something has travelled in the totality of its journey. Okay, so common units you'll see used when we're talking about distance are millimetres, the abbreviation centimetres, metres, kilometres, miles, and there are many more units of distance, but these are the most common ones you'll see in our examples. Okay, next one is our time. So this is how long something is travelled for. So if we're talking about a journey, time specifically means how long that journey has lasted. Again, common units here are things like seconds, minutes and hours. They're the most common ones we'll be using, generally seconds and hours most. Okay, and the last one will be speed. Now speed is how fast something travels. Okay, that's a slightly trickier concept. Basically it's the distance something covers after a certain amount of time. So this is a mixture of your distance and your time is what your speed is. And common units of speed would be like a really common one here is meters per second. So this is every second, whatever is taking this journey is covering a certain number of meters. Kilometers per hour, miles per hour, which you're probably aware of. Okay. So just as a wee example for speed, if I think of something travelling at 5 meters per second, what I'm saying is whatever it is, this thing travelling at that speed, it means every second it's travelling 5 meters. So every second it's travelling 5 meters. If I think of a car travelling at 30 miles per hour, then that would mean that the car is travelling 30 miles every hour. Okay, so every hour the car travels 30 miles. So that's our speed. And again, there are many more units, but these are the most common ones we'll be using. So we're going to jump into a few examples here. Okay, so first one is some calculating distance. So to calculate our distance is just our speed multiplied by time. So you'll see in example 1 here, we're talking about some car travelling at this speed, 60 miles per hour. We want to know how far it travels after 4 hours. Okay, so this is calculating distance. And the formula up here, distance equals speed times time. We just need to know what our speed and what our time is. So our speed here is this miles per hour. Remember, that's a unit of speed. So this means the car is going 60 miles every hour. And our time, which I'll highlight in green, as well, our hours is a time unit, so 4 hours. So our speed and our time. So to calculate distance, well, distance is, like the formula says, speed times time. So our speed is 60, our time is 4, so 60 multiplied by 4, which is 240. Okay, so what we've worked out here is that this car is travelling 60 miles every hour and is going for 4 hours. So in total for those 4 hours it's going to travel, every hour it's travelling 60 miles. So in total it travels 240 miles. So our distance unit here is miles. Okay. So example 2. A man runs for 25 seconds at a speed of 8 meters per second. How far did he run? Okay, so let's look for our speed first again. So our speed, well, we have 25 seconds, but seconds by itself is just a time unit, so that's actually our time. So our speed must be the 8 meters per second. So every second this man is running 8 meters, so 8 meters every second. But the question's telling us he's going for 25 seconds. So to work out the total distance he runs, well, we use our wee formula. So distance is speed multiplied by time, which is speed was 8 meters per second, so 8 multiplied by the time, which is 25 seconds. Okay, so 8 25s comes out to be 200. So for 25 seconds, every second he's running 8 meters per second. 8 multiplied by 25 is 200, and that would be meters because that's the unit of distance we're using. So it's 200 meters, which I'll just put as an M. That's fine to leave for meters. Okay, so that was a couple examples working out distance using our distance formula. Second one we're going to look at is calculating speed. So you can see our formula here, speed is distance divided by time. Now another way we could write this formula is, I'll just write it underneath speed. We can do this as a fractional notation as well. So distance divided by time, we'll mostly be writing it as d over t instead of t divided by t. Okay, so d over t just means the same thing, distance divided by time. Okay, so let's look at our question and see what we have. So we have our 3 hours, so calculate the average speed of a car if it travelled 48 miles in 3 hours. So we're talking about miles and hours, so we kind of want to know how many miles per hour is it going. So every 1 hour, how many miles does it travel? So it's travelled a total of 48 miles in 3 hours. So our time here is our 3 hours, because hours is a measure of time. And our distance, which is our d there, our distance, well, that's 48 miles, because miles is a unit of distance. Okay, so if we go into our formula again, speed is distance divided by time. Now we'll do this with the divide sign first instead of the fractional notation, just so you've got an example of doing it both ways. So distance divided by time, so that's 48 divided by 3, which ends up being 16. So in 3 hours, this car travelled 48 miles. So we want to know how much it travels in 1 hour. So we divide the 48 by 3. So in 1 hour it must have travelled 16. So that was miles per hour. Every hour this car is travelling 16 miles on average. Okay, so example 2. So Blair completed 75 metre egg and spoon race in 15 seconds. A pretty good time, I'd say. What average speed was he travelling at? So again, our formula, I'm going to write this in fractional notation this time. So speed is distance divided by time. Okay, just writing as a fraction, but just because you'll generally see it this way, but it means the same thing. So our distance, let's look at our question, see what we have again. Let's see our time first. So we've got 75 metres, so that must be a unit of distance because that's metres, and 15 seconds. So the seconds is a time unit, and the 75 metres is our distance. Okay, so we're doing distance divided by time. So my next line is to put our numbers in, so distance and time. So our distance was 75 and our time was 15. Okay, so 75 divided by 15, again the fraction just means to divide. 75 divided by 15, which is 5. Now again, need to put our units in. So I will again look at the question. So 75 metres over in a total of 15 seconds. So we want to know our speed here would be in metres per second. So how many metres did he travel every second? Well, there's 15 seconds, so we divide by 15. So he must have travelled every second. He must have travelled 5 metres. So 5 metres per second. Now, just incidentally, for metres per second, you may sometimes see it as this with a wee -1 at the S. Now we will go into this in a lot more detail when we do indices, but it means the same thing. So if you ever see this, that means exactly the same as dash S. Okay, so they mean the same thing, metres per second. And the last one we're looking at is calculating time. So, example 1, Lily walks 12 kilometres at an average speed of 4 kilometres per hour. How long did the walk take her? Okay, so again, this is calculating time this time. So we know our formula for time is distance divided by speed. And again, like we did for speed, this division sign, we don't need to write the division sign. We can write it as a fraction again. So time is distance over speed if we want to. Okay, right, so let's look at the question and see what information we've got. So let's see if we're looking for a time, so we should have a distance and a speed. So Lily walks 12 kilometres. Okay, so 12 kilometres must be a distance. So that must be our distance. And our speed, well, 4 kilometres per hour. So that's definitely a speed. So that's the distance travelled over some time. So that's a speed. Okay, so distance divided by speed. We know our distance was 12 and the speed was 4. So 12 divided by 4, which is 3. Okay, so every hour, Lily is walking 4 kilometres. She's walked a total of 12 kilometres, so that must have been 3 hours she was walking for. So 3 hours would be our unit there. So a unit of time would be hours. And example 2, how long does it take a train travelling at 80 miles per hour to travel 40 miles? Okay, so again, let's have a wee look at, see if we can work out our distance first of all. So the train's travelling at 80 miles per hour, so that must be a speed unit, miles per hour. So 40 miles is the distance travelled, so 40 miles. Therefore, we've already identified our speed must have been the 80 miles per hour. So, again, if I go to set up my formula, so time is distance divided by speed. Again, we're going to write this as a fraction just because you'll see this probably more often. Distance divided by speed, so distance here was the 40. And we're dividing that by 80. Okay? So what we actually end up with there is 0.5. Okay, so a wee decimal, that's just totally fine. So the time came out to be 0.5. Now, all we need now is our units. So this was, she travelled 40 miles. The train travelled 40 miles at 80 miles per hour. So every hour the train is travelling 80 miles. If it's only travelled 40 miles, it's only gone half an hour or 0.5 hours. So that must be hours. Okay, so at the start of your workbook, you'll see the first 3 stages, 3 steps are calculating distance, speed and time. So you can have a go at those questions now. Okay, thank you, bye.